Okay, let's jump right into this explainer and tackle an immense frustration I know so many of you are feeling right now. You're out there trying to build custom AI agents to automate your workflows, but instead of this smooth, futuristic operation, it's kind of turning into a chaotic, unmanageable mess, right? Well, today we're going to fix that by walking through the definitive playbook for process mapping. So I really want you to ask yourself, why do your agentic systems keep breaking? Think about it. You're probably using the absolute newest, most advanced models out there. You've got access to incredible computing power. And yet, the second you deploy these agents into an actual real-world business workflow, things just go off the rails. It clearly isn't a problem with the AI's intelligence. So what exactly is going wrong here? Look, we have all felt this pain. When you just throw agents at a problem, hoping for the best, you end up with way too many handoffs between tools and a ton of hidden assumptions. You get these endless, sprawling chat histories that cause what engineers literally call brain rot, where every extra decision path just exponentially multiplies the complexity of your system. You end up stuffing way too much context into the agent's prompt, crossing your fingers it'll figure things out. And when it inevitably fails, there's absolutely no obvious place to debug it. You're just left guessing. To untangle all this, here is our agenda for today. We'll be looking at the Agentic AI chaos, why process mapping has to come first, how to model the real world, workflow to architecture translation, and finally, designing for debugging. Let's start with Section 1, the Agentic AI chaos, and why we really need to stop adding agents to broken processes. The absolute most crucial point to understand is this. Agentic AI is not a prompt problem. It is a process and domain modeling problem. The issue is that most teams start with entirely the wrong questions. They ask, hey, what model should we use? Or what framework should we build this in? Or even, can we just add another agent to double-check the first agent? We literally need to stop asking those questions and start looking closely at the actual process we're trying to automate. Which brings us to Section 2, process mapping comes first. We're talking about documenting the reality, not just the SOP. A standard, neat little flowchart just isn't going to cut it here. True process mapping requires documenting the messy reality of the work, not what the perfectly polished standard operating procedure document claims happens. You absolutely must map what actually happens on the floor. Like, what actually triggers this task? What's the real, tangible output? You have to dig in and uncover that undocumented tribal knowledge. You know those little workarounds your team uses every single day just to get things done? You have to explicitly map out the exception paths, the error hotspots, and exactly where a human approval steps in. Because if your map ignores the exceptions, your agent is going to break the very first time it hits one, for sure. All right, moving to Section 3, model the real world, using Palantir's ontology mindset. To build a solid foundation, we're going to borrow heavily from Palantir's field-tested ontology guidelines. They treat their ontology like a digital twin of an organization, and honestly, it's the perfect mindset for agentic AI. This brilliantly illustrates the massive paradigm shift you need to make. Just think about bad modeling, mirroring source tables, and naming things for your database. If your agent is forced to operate on an object called sheetrow_3 or CRM_record_alpha, it's going to get super confused, and honestly, so are you. But with good domain-driven design, you model actual domain entities and name them for humans. Your agent should be operating on meaningful business objects you can instantly recognize, things like client, proposal, or vendor. Palantir also has this really fantastic operational secret called the Rule of 3, and I highly recommend burning this into your brain. If you build the exact same object, the same derived property, or the same chunk of logic 3 times in your system, well, it's time to stop, refactor, and consolidate. Don't let your system bloat up with near identical types. 1 instance is a coincidence. 2 might be a pattern, but 3? That means you absolutely need a single canonical representation. And to avoid all that nasty duplication, we lean into this concept, composition over deep hierarchies. Instead of building these massive, rigid, brittle inheritance chains where tweaking one thing at the top breaks everything at the bottom, you want to use capability-based interfaces. Make sense? So if a thing needs to be scheduled, give it a schedulable interface. If it needs human sign-off, slap an approvable interface on it. This keeps your whole system incredibly intuitive, highly reusable, and far, far easier for an autonomous agent to navigate without getting totally lost in your database architecture. Okay, Section 4, Workflow to Architecture Translation. This is your blueprint for scale. This explicit architecture perfectly defines our boundaries. It shows you exactly where agents belong, and importantly, where they don't. If a step involves fixed rules, Use deterministic code. Please don't waste an expensive agent on that. If you just need pattern recognition, run a standard LLM call. But when you hit branching uncertainty, where the right path forward isn't clear until the data is actually analyzed, that is exactly where you place an agent. Meanwhile, an orchestrator handles the cross-step coordination, and humans step in purely for accountability and approval. I know that can sound a bit abstract, right? So let's make this incredibly concrete. To prove how this workflow to architecture translation actually works in practice, let's map out a real-world scenario. We're going to use the daily operations of an SEO content agency as our case study here. So here is how that agency operates when the system is actually designed correctly. Step 1. Intake and qualify the client request. That's a fixed rule, so we just use deterministic code. Step 2. Researching keywords and competitors. That's pattern extraction, meaning a standard LLM handles it perfectly. Step 3. Drafting and revising the content. Now here we have branching uncertainty. Maybe the draft needs 3 major revisions, or maybe just 1, so this is where we deploy an agent. Finally, Step 4. Final approval and publishing. That requires real-world accountability, so it's a human. By typing each workflow node this clearly, we establish super strict autonomy boundaries that keep the whole system completely safe, predictable, and operable. Which brings us to our final part, Section 5, Designing for Debugging, how we make failures visible and fixable. Because we modeled the domain first and strictly defined our boundaries, a really good process map can instantly answer key debugging questions. If your system stalls out, you know exactly what triggered the action and what exact object the agent was acting on. You know if it was an input failure, a retrieval issue, or a tool failure. You know if it was blocked by a hard policy or if it's just sitting there waiting on a human delay. And ultimately, you know exactly who has the authority to override it. You no longer have to mentally reconstruct the system state by reading through hundreds of lines of sprawling chat logs. The failure is completely visible, it's isolated, and most importantly, it's easily fixable. So I want to leave you with this provocative thought to take back to your engineering teams. Are you just adding agents to a fundamentally broken process, or are you actively redesigning the process for agents? We have to stop building chaos. Fix the process map and fix your underlying ontology first. If you do that, I promise you, your agentic architecture will naturally and beautifully fall right into place. Thanks so much for joining me on this explainer, and I'll catch you next time.